Hello everyone, today I will show you the schematic diagram reading of LG 49UJ634v TV power boards. In this tutorial I will show you identify the section or the components of power board and read the flow of electrical current passes and to show the main checkpoints of the power board. First, we'll identify the sections of this power supply. In this power supply we have different sections. The first one is the protection circuit here. From this point up to this point is the protection circuit. In the protection we have electromagnetic interference remover, which is the inductor and the capacitor. This is to remove unwanted signal from the boards or the circuits. The other protection circuit in this tip is over voltage protection. Here is a VDR or voltage dependent resistor that is protect the circuit when coming high voltage from the utility by vary the resistance value of the component. At normal condition this component have high resistance, but when the voltage increase from the utility to decrease or reduce the resistance of this component by itself and to trip the circuit breaker and the fuse. The other one is overcurrent protection here. This is a fuse to protect overcurrent in the circuits. So this is very important circuit to protect the power supply from the injury. This one is the bridge circuit or the bridge rectifier, which is convert the incoming AC voltage to DC voltage. The other circuit is PFC and booster circuit. Here is PFC IC, here is a booster circuit here. That is used to boost the voltage from low level to high level. In this case, we boost the voltage from 300 volts to 400 volts. That is used to stable the output voltage or the working of the other circuit in the television. The other circuit is here the multi-circuit or the multi-circuit and standby circuit here. This one is the IC, which is include standby IC and multi-IC. That is used to for out standby voltage and multi voltage for the TV. The other one is here the chopper transformer. This one is to transfer the frequency from the multi-switch transistor to the secondary sections of the power supply. So here the rectifier diodes that is to convert the incoming signal from the chopper transformer to DC. Here the filter circuit to smooth the ripple AC voltage from the rectifier diode. The other one is here is the feedback. This one is used for control the regulation systems of the power supply, which means to constant output voltage in the secondary sections of this power supply. So this feedback is very important. The other one is this one is also the power on lines, which is transfer the power on signal from this section to the main IC and to the PFC IC. The other one is Backlight Driver Ic. This one is used to drive the backlights, which is control the brightness of the backlight depending on the signal coming from the main boards, which is PWM signals. So now I will show you the main points of this schematic diagram. So when we plug AC voltage here, in our country standard 220 up to 240 AC volt with 50 Hz, but in European standards we supply 110 voltage with 60 Hz. So this voltage is transferred directly the bridge rectifier without changing or without reducing or without updating the voltage. This voltage 220 voltage reach in the bridge rectifiers. So this circuit is the only function is to protect the circuit, is not reduce or is not update or increase the incoming voltage. So if the overcurrent protection fuse, over voltage protection, electromagnetic interference remover, inductor, capacitor is normal, this point voltage also get in these points. So this bridge rectifier filter, this is rectified this AC voltage to DC voltages. So in this point we will get DC voltages. So this is bypass diode to transfer the DC voltage without changing. Also here are filter capacitors. After the filter capacitor, look this line coming to the PFC IC. Look this one, PFC line voltage for PFC IC. The other one is for the multi IC. So this point is the one critical point. The other one is, look these pointers. Here is the arrow, which is indicate output arrow. These pointers and these pointers connect through this one. So here is a diode that is rectifier or to convert the AC voltage to DC voltage, because in this point we have AC voltage, because this point is before the bridge rectifier. So this point directly connected to this one, and we have AC voltage here, and this AC voltage rectified by the help of this rectifier diode and filtered by the help of inductor, and the DC voltage transferred to this IC by pin number 1 and by pin number 18 and by pin number 1. So in this case, when the voltage input in this IC by two directions or by these 2 pointers, at this time this IC start minimum working. So in this case, when input these 2 voltages, this IC start minimum working, and out the voltage for 2 switching transistor here. This is fast switching transistors to receive the minimum voltage from the multi IC and make a frequency by on off, and that frequency transfer to this chopper transformer. Look this line is the output lines of these 2 transistors, and transfer to directly the chopper transformer. So the function or the application of this chopper transformer is to transfer the frequency from the primary side to secondary side. In the secondary side we have a diode. This diode to rectify the incoming AC voltage from the transformer, and by filter the help of this capacitor, and we will get 7.8 voltage in these pointers when our TV in standby mode. So at the same time from this point the frequency transfer to these pointers, because here is a coil, also here is a coil. By the help of magnetic flux, the frequency transfer from this coil to this one, and its frequency rectified by the rectifier diode, filter by the help of capacitor here, and make develop VCC voltage for multi-IC here, multi-IC VCC voltage. So in this step our TV is in standby mode status. So in standby mode status, your TV show a red light in the bottom sides of our TV. That is indicate for us my TV is in standby mode. So we need to a signal from our shelves or from our shelves to send the TV. So when you press power on button on the remote or in our TV, at that time the power on signal transfer from the IR PCB into the mainboard, and that signal also transfer from the mainboard to these points. This is a power on signal, means transfer this signal to this port to prepare different voltages, or to out from standby mode to working modes. So this power on signal transfer from the mainboard to these transistors, from the base point to collector pointers, and transfer into the optocoupler. Transfer this optocoupler to this transistor, series transistor regulators. Look here, this point is directly connected to this one, means this transistor also get the voltage from these points. So this transistor series regulator to regulate or constant output voltage from these pointers. So in this point we have constant voltages, so that voltage the transfer to the PFC IC pin number, this one, pin number 8, and also these pointers, look, coming up to the multi-IC. So now the multi-IC and the PFC IC start for working. So when the PFC start fully working, we have output voltage from PFC IC to these switching transistors. So these switching transistors, by making on-off signal to boost the voltage from 300 voltages to 400 voltages. In standby mode, in our power supply main filter capacitor, we have 300 DC voltages here, depending on the incoming voltage. When reduce or increase the incoming voltage from 240 from 220, also the voltage will be increased. So this voltage is depending on the incoming voltage. But when the booster circuit and the PFC circuit is working, in this point we have to get 400 voltages. The multi-IC also working fully, means out high voltages, HV and LV voltage for these two switching transistors. So these two switching transistors by cut off the DC voltage from the multi-IC and will prepare AC voltage for chopper transformer, and then this chopper transformer transfers the voltage from primary to secondary. At that time your TV is in working mode, so the voltage in this point is 13.2 voltage. Also the backlight voltage will be out. This one, the backlight voltage out point is, this point is connected with this one. So when the output voltage 13.2 voltage out, also this is for this IC. So this IC also drive the backlights. The backlight will turn on. So this one is the schematic diagram of LG 49UJ TV. Schematic diagram reading. Enough for today. In the next section I will show you these main test points. In practical, measure the voltages, how much the voltage we have in standby mode in each testing points, and how much the voltages in working modes. Thank you for watching this video.